Hello friends, today we are going to learn about the series combination of the resistors. Okay, so we all know about how the resistances are connected in the series. The resistances are connected in the series is by end to end. Like that, suppose we have resistance number 1, resistance number 2 and the resistance number 3, which is represented with R1, R2 and R3. So this is the series combination of the resistors. Now let us connect this resistance with the battery, which has one positive terminal and one negative terminal. And also we know about that in the series combination of the resistance, current flowing through that all the resistance is equal. Okay, suppose here current I passing through the circuit, so this I will passing through R1, R2 and R3 and come back to the negative terminal of the battery. Okay, now suppose this battery voltage is assumed at V volt and voltage across this resistance R1 is V1, voltage drop across V2, voltage drop across R3 is V3. Okay, now as per the Kirchhoff's law or as per the Kirchhoff voltage law, we can say that the total voltage drop across this circuit is equal to the supplied voltage in this circuit. So here supplied voltage is V and the voltage drop is V1 plus V2 plus V3. Okay. Now as per Ohm's law, the voltage drop across any resistance is equal to the current passing through that resistance multiplied with that resistance. So here the voltage drop across R1 is V1 and is equal to the IR1. Similarly, V2 is equal to IR2 and similarly V3 is equal to IR3. Okay. Now if I say that instead of these three resistances there was a single resistor connected with this battery such that the same current flowing through that resistors, so we can say that that particular resistor will give us the equivalent resistance of all these three resistances. So here I make another circuit. Let us its name RS, which is connected with battery V and current passing through the resistor is I. So here also the voltage is equal to IRS as per the Ohm's law. Now put this all the values in this equation. Okay, let us equation number 1. Put this all the values in equation number 1. So V is equal to IRS is equal to V1 is equal to IR1 plus V2 is equal to IR2 plus V3 is equal to IR3. Now if you observe that we can take common I from all the terms. So here I am going to take common I from all the terms. So I in bracket R1 plus R2 plus R3 and this side IRS. So here I and this I both are the same, so this I will be cancelled. So RS is equal to R1 plus R2 plus R3. So this RS is the equivalent resistance of all these three resistances. Okay. Now from this equation we can conclude that In the series combination of the resistances, the equivalent resistance are sum of all the resistances. Okay, and also we can observe that the equivalent resistance in this series combination of the resistors is always greater than the any particular resistances. How this? What is this? This is the equivalent resistance of the series combination of the three resistances. Okay, is always greater than the R1 or R2 greater than the R3. So in the series combination there is the 2 point. Point number 1, equivalent resistance is equal to the sum of all the resistances, and point number 2, the equivalent resistance is always greater than any particular resistance in that circuit or in this series combination. Okay, thank you so much.